All right, so last class we talked a lot about linear equations and how to write them in some different ways, how to pull information from them. And so today we're going to skip to chapter 2. And we're going to look at kind of the building blocks of a lot of the different types of equations that we'll be looking at this semester. So we'll be talking about some specifics about things called functions and what we can tell about their graphs. So first let's define what a function is. A function is just simply a relationship between two variables. A lot of times that's going to be x and y, but especially in this business math class, we may be using different variables. But there will be one independent variable, often called the x, and then one dependent variable, often called the y. But here's how you tell if it's a function. It's not just a relationship. It has to follow this rule. Each x has to be paired with only one y. In other words, there's no x that gets repeated. Okay, so when we speak about functions, often we will break down functions and we'll talk about their domain and their range. And so domain is basically what x values you're allowed to have given a scenario, and the range is the y values that you're allowed to have. So a good rule of thumb to memorize which is that domain and range are in alphabetical order, right? D comes before R alphabetically and x comes before y. So when we have a graph of any type of equation, we should be able to visually tell if it's a function through something called the vertical line test. And here's what the vertical line test basically says. Any vertical line can only pass through the graph of a function once. So if it can pass through the function more than once, then it is not considered a function. So certainly most lines that we talked about last class would be considered functions. Notice a vertical line. If you consider this pin right here to be my vertical line, right, I could slide my vertical line anywhere, okay, and it would still be a function. We'll learn about these in more detail pretty soon in this class, but this is a parabola, okay, and notice it also passes the vertical line test because you could slide a vertical line anywhere, okay, and it would still only cross the graph once. So that's definitely not an exhaustive list, but these two things are certainly functions. So some things that are not functions are anything that's circular / oval in shape, definitely not. Anything where a vertical line could pass through the graph more than once. So even the special case vertical line would definitely not be a function. Because if you think about it, a vertical line could be drawn on top of that one and it would actually hit every point, which is certainly more than one point, right? So these are not functions. Okay, so the vertical line test can be really useful, but what about when you don't have a graph? Well, sometimes we will probably benefit from either looking at a graphing calculator or just plotting a quick graph, and then we can perform the vertical line test. Okay, so let's say we wanted to know if this is a function, and maybe we don't have a calculator on hand. So you can always, your fail-safe is always that you can plot your own points and then just kind of connect them and figure out what shape you have. And we do that by choosing some x's and putting them in a table, and then we plug those x's in to find their paired y's. So my go-to x's are typically a couple negatives, 0, and a couple positives. You want to keep these x values small, although you can choose anything. Remember, you're going to have to graph these points. So you could choose 100 for x if you want to, but nobody really wants to graph an x value of 100, so kind of keep that in mind. So you're going to take all these x's that we just chose and you're going to plug them into this equation to get your y's. So negative 2 squared is 4. Remember, negative times a negative is actually a positive. So negative 2 squared is 4 plus 1 is 5. Same thing here, negative times a negative, so it'd be negative 1 times negative 1, which is 1, plus 1 is 2. Plug in 0 and you'll just get 0 squared plus 1, which is just 1. And then 1 squared plus 1, that would be 1 plus 1 or 2. And then lastly, 2 squared plus 1, so 4 plus 1 or 5. Okay, so basically then we can just kind of sketch a graph. So I'm going to go out 5 in every direction because based on the table and the x values that I chose, 5 is the biggest value that I have represented. You can always go bigger if you need to. So I'm going to plot these points. So I've got negative 2, 5. I've got negative 1, 2. I've got 0, 1, 1, 2, and 2, 5. So I end up with actually a parabola curve, kind of like the one I drew above. Okay. So now the question is, now that we do have a graph, and remember you also could graph it on your graphing calculator. Okay, so we'll go ahead and do that really, really fast. Okay, so if you wanted to, you would go to your y equals. Let me try to get it out of the glare. So go to your y equals and you'd enter in x squared plus 1, and then you'd choose graph. Okay, but again, you may not always have access to a graphing calculator, and I am going to want you to be able to graph basic things, basic functions on your own paper with the detail that I would want to see. So notice they're pretty much the same, right? But at any rate, if we figure that this is our vertical line, no matter where you slide this pin, right, it does pass the vertical line test. So the answer to this would be yes. It passes the vertical line test. We also could kind of look at our values that we have and notice that no x is repeated. So really for a lot of reasons, the answer is yes. Okay, so once we've determined something to be a function, we typically write function equations a little bit differently than just y equals. And so notation is just the symbols and format that we use to write things in math. So function notation looks like the following. Okay, so f of x is how you say this. It does not need to be the letter f, okay? Frankly, it doesn't even need to use the letter x, but you will see a letter, parentheses, followed by either a number or, in this case, a letter, okay? But what I do want you to realize is this is just another way to write y. Okay, it's just this format is going to allow us to do a whole lot more than the y equals notation allows us to. So, let's do a really quick example just to kind of highlight that. So if I wanted you to rewrite the equation we just plotted in example 1 in function notation, then you would rewrite that as f of x equals x squared plus 1. So function notation does a couple of things. It lets you know just with this notation that yes, you are dealing with a function, but it also informs you with the letter that it uses here, like what letter will be used in the equation. In other words, this is going to be a function involving x. That's kind of what that means. Okay. So with this function notation comes some questions that we can ask. So using this same equation, we're going to find f of 3, f of 0, f of a plus 1. And then as goofy as it sounds, we're going to do f of Texas just to kind of prove a point. Okay. So when you're asked to find f of a value, you're being asked to find what is the function value when x is 3. Okay. So this means find the y when x is 3. Okay. In other words, it means plug in 3. Okay, so you go to your f equation, which looks like this, and you're going to replace x everywhere there's an x with a 3. So it would look like 3 squared plus 1. Okay, make sure you do your order of operations. Okay, so we would do 3 squared first, so 9 plus 1 is 10. Okay, so what this means is the meaning of this answer is the y value is 10 when x is 3. Okay, so the answer you're getting for an f of x or f of number expression is the y value. Okay, so when you're asked to find f of 0, same process, but in place of x this time we're going to replace it with 0. So we'll do 0 squared plus 1, which is, in this case, 1. Okay, so again, the meaning of this is that the y value is 1 when x is 0. Okay, but what about when you're asked to find f of something else other than a number? Well, the answer is you don't do anything much different. You're just going to now be inserting whatever's in the parentheses in for the variable that you're using in the original equation. So in place of x, I'm going to replace it with a. So it would just look like a squared plus 1. Okay, that's as far as we can go with that because a squared and 1 are not like terms, so we can't combine them or do anything fancy like that. But notice, f of a literally just means plug in a. Okay, like whatever shows up in the parentheses, that's what you're going to plug in. Okay, so probably the toughest one in this example. What about f of a plus 1? Okay, and the answer is it does not matter what is here. Okay, whatever is listed here, it just means you need to plug in all of it. So we need to plug in a plus 1 everywhere there's an x. So in place of x, instead of x squared plus 1, we're going to get a plus 1 parentheses squared plus 1. Okay. So before you try to quickly do something that you can't do, you're not allowed to distribute a square when you're adding. So don't try to say that's a squared plus 1 because it's just not. What it is squared means something times itself. So this is actually what we have here, and then hopefully you kind of recognize this as a two-part thing by a two-part thing, and we reviewed this the first week of class, but we would actually need to use FOIL here, first, outside, inside, last. Okay, so a times a for first is a squared, a times 1 for outside is a, 1 times a for inside is another a, and then 1 times 1 is 1. And then don't forget this plus 1 here too. Okay, in other words, I got a plus 1 from the L step of FOIL, but then I still had my plus 1. So now we can combine like terms, so we get a squared plus 2a plus 2. Okay, and that's as far as we can go. Notice nothing I have left is actually like terms, so I can't combine any of those. Okay, and then I only put this one on here really just to prove a point. My point with asking you what is f of Texas, I know that doesn't really make mathematical sense. My point is I don't care what's in the parentheses. Whatever's in the parentheses, you're going to replace x with that. Okay? So in other words, instead of x squared plus 1, we're going to have Texas squared plus 1. Okay? Doesn't really, again, have a whole lot of mathematical meaning, but that's what we do. Okay? Whatever is in the parentheses, you replace every x in the equation with that quantity. Okay, in this case, it happened to be the word Texas. Okay, so as strange as that is, that's what we would do there. All right, so now I want to also look at being able to maybe use this function notation and draw something from a graph we might see. So your graph doesn't have to be super perfect, okay, but I want you to draw an axis that goes out 3 in every direction. And then we're going to mark a point at 0, 1, and then this is 3, 0, and then the last point is going to be negative 3, 2. So my intention is that this is a perfect line, but I didn't necessarily space all my values out perfectly, so it's an okay line. So based on this graph, let's say that I wanted you to find some of the same things that I asked you to find in example 2. So I want you to find f of 0. Maybe skip some space, so if we need an explanation under it, we can. I want you to find f of 3. And then I want you to try to tell me for what x value is f of x equal to 2. Okay, so notice I'm asking you, except for part C, parts A and B are very similar to what I asked you in example 2, but this time you don't have an equation to plug into, right? So I'm asking you for something similar, but how are we going to find it? Okay, well remember, this just represents a y value of some sort. Okay, so what this is asking for, and I'm going to skip some space so I have some room for my answer. What this is asking for is, what is the y value when x is 0? Okay, that's what f of 0 means. Okay, so what is the y value when x is 0? Well, here's x equals 0, right? So what's the y value at this spot? Notice the y value is 1. So f of 0 for this graph is 1 because the y value when x is 0 happens to be 1. Okay, so let's see if we can answer this question now. F of 3 equals what? So again, this is your y value. Okay, in other words, the whole f of 3 is the y value. Okay, I'm asking you to find the y value when x is 3. So again, we'll skip some space. Okay, so here's x equals 3, and what's the y value right here where I'm pointing? Notice that it's 0. Okay, so notice in part C I change it around, right? This time I'm telling you already what the y value is. I'm telling you that f of x already is 2. Okay, so I'm telling you the y value, and I'm asking you to tell me the backwards of what I asked you to find here, right? I gave you the y, I'm asking you for the x. So find the y value of 2, which is here, and now you just kind of trace it down and figure out what x value it was. So notice the x value of negative 3 is what gives us a y value of 2. Okay, so just make sure you realize when you see f of x, when you see f of 2, when you see f of 0, all of those things in function notation, f of something means find the y. Okay, so let's practice maybe one more with function notation, and then I think we'll move on to something else. So for this one, I want you to find 3 things. So what I'm asking you to find for these function values might seem a little tedious, but actually there's a lot of meaning to what I'm asking you for, especially in part C for this example. This is an example of an expression that we look at a lot in Business Math 2. Okay, the class after this one is Business Calculus. This is Business Algebra. And so this is just kind of giving you an algebraic taste of something that you're actually going to spend quite a bit of time on in 1325. Okay. But you don't really need to know that. I'm just saying I didn't pull this equation out of the air. It actually has some significance. It's called it's called a difference quotient. Sorry, I forgot the name for a minute. It's called a difference quotient, and it has some very specific, very important meaning in business calculus. All right. But let's pretend we don't know that. If I say find f of x plus h, remember the Texas example. It doesn't matter what's in the parentheses. It just means go replace x with whatever that parentheses says. So in place of x, I'm going to have 4 parentheses minus 3. Okay, and then I clean up anything I can, because notice I can do distributive property here. And so I would. So I would do 4 times x, which is 4x, 4 times h, which is 4h, and then minus 3. Notice the 3 does not get multiplied by the 4 because it's not part of the parentheses. Okay, so all we did here is we just plugged in whatever was in the parentheses. It just so happened that the parentheses had 2 letters in it. We don't care. Okay, we plugged it into the equation. All right, so without reinventing the wheel, let's see if we can figure out what this quantity is. Okay, f of x plus h minus f of x equals what? Okay, well, the reason I said don't reinvent the wheel is because you already did the heavy lifting for this back in part 1. okay, or part A. We already found f of x plus h to be 4x plus 4h minus 3. So we don't need to find it again. We already did the work there. This is the f of x plus h portion that we got from part A. And then notice it's asking us to subtract off f of x. Well, we were given f of x originally, right? F of x is equal to this 4x minus 3. So make sure you use parentheses because it's minus the whole entire f of x. Okay, so if I distribute this minus sign, and I would want to, it's just essentially going to change all the signs of what I have. So I'm going to end up with 4x plus 4h minus 3. And then I get minus 4x plus 3. Okay, so combine any like terms, which we actually do have some, right? 4x take away 4x is 0. Negative 3 plus 3 is 0. So actually a lot of things simplify and kind of cancel out, and I just end up with 4h. Okay, that was all that was left for step B. And then step C is just to take what we just did in step B, but put the whole thing over h. Okay, so basically part C is the significant equation, but we just did kind of baby steps to get us there. We didn't want to go full-blown this ugly thing right here, so we did stages until we can get here. So notice, we already did the whole numerator in part B. We already figured out what f of x plus h minus f of x was, and it was equal to 4h. So now I just need to put what I got in part B over h, basically. Okay, but then notice that we have an h in common. And so in the end, we end up with just getting the answer of 4. Okay, so again, just know that that has some significance for you later on, but for now, all you have to do is just practice this function notation. So f of whatever just means go to the equation and plug in that parentheses, whatever happens to be there. Okay, so because this is business math, I think we kind of touched on cost last week, but I wanted to kind of take a break and make sure that everybody's on the same page because, you know, some of you have taken economics before, some of you are taking it with this class, some of you haven't taken it yet, so I want to make sure some basic economic terms are kind of out of the way. And so we usually use capital C of X in function notation to talk about cost. Cost is the total cost for producing X items. So there can be many things wrapped up into the cost of producing things, right? I mean, you have like the building rent or the mortgage payment, depending on, you know, what it is, or the business payment. You have to pay your employees. You have to pay your electric bill. You have to buy supplies to make whatever it is the item is that your company makes. So cost is usually wrapped up in quite a few things. Okay, but C of X is the total cost. So all of those things I just mentioned and more get wrapped up into the total cost. Okay, so revenue, on the other hand, we usually use R of X to represent that. Revenue does not talk about costs at all. It's actually the total amount that we earn from the sale of selling the items we made. It doesn't mean that we get to pocket all of that if we're the business owner, because we actually still have to pay costs. Okay, so in other words, it doesn't really do much good to make $1 million in sales if you also have to pay $1 million to make that million. Okay, you don't actually get to keep any of that. So profit is actually the bottom line of where we really want to know how a business is doing. Not surprisingly, we use capital P of X. Okay. By the way, we use lowercase p. We're going to talk about that in a minute. We use lowercase p in business math to represent price. We use capital P to represent profit. So it is kind of important that all of these letters happen to be capital. Okay. So P of X is basically the total amount kept after costs are paid. So a lot of times when you hear about how well a business is doing in the news or something, a lot of times they're actually reporting the revenue. Like sometimes when they say, oh, this is a multi-million-dollar company, well, my question is how much of this money are they actually keeping? Okay, is that profit or is that just the sales that they're making and then they still have, an equal amount in cost, which, really wouldn't amount to anything in their pockets? So this is a relationship that I either want you to memorize or just kind of logically think about why it's true. If I want to know the profit, what I really need to know is how much money did I bring in minus how much money did it cost me to make that money. Okay, and the difference will be the profit that I actually get to keep in my pocket. Okay, so capital P is profit. On the other hand, lowercase p is almost always reserved for price. So you might see a lowercase p of x equation with maybe a demand function. And so this would just be the price for x units demanded. Because in economics we learn that price is not always constant. Okay, we sometimes have to change the price of items, or sometimes it's kind of changed for us. But basically you can charge more for an item if the demand is high. Usually, typically, you cannot charge a huge quantity or a huge price if there's really, really low demand. Nobody wants to buy your product, so they definitely don't want to pay a high price for it. There are definitely exceptions where people will pay just about anything just because they need the item, but anyway, demand is usually wrapped up in, or price is usually wrapped up in demand. Okay, so this would be an example of a linear demand function where x is the units demanded. So I really just wanted to kind of introduce to you a lot of this function notation, a lot of kind of what letters we reserve for what. So capital C, R, and P are usually reserved for cost, revenue, and profit, and then lowercase p is almost always reserved for price. Okay. Okay, so let's look at a few more things about domain and range, probably more specifically about domain, but so when we discuss the domain and range of a function, we almost always use interval notation. So if you are unfamiliar with interval notation, you're definitely going to need to learn it. Okay, so here are some facts about interval notation. First of all, you use parentheses for either positive or negative infinity, and you use it when you are not including the endpoints. Okay, so we're going to do some examples here in a minute, but we use parentheses for either positive or negative infinity, or when we have an open circle, basically. That's what it means when we're not including the endpoints. And we use brackets when you are including the endpoint, or with a solid circle. Okay, so here's what the interval notation is going to look like. For domain, now domain we already mentioned was the x values, right? So remember, which axis would be the x-axis, the vertical or the horizontal one? Okay, if you think about how a graph is drawn, the x-axis is the horizontal one. So I only care about the horizontal values. In other words, I'm going to start off with a parentheses or a bracket, depending on whether we're including the endpoint or not, or maybe whether we're using infinity. And then you're going to begin with the left starting value. And then you're going to have a comma, and then you're going to end with the right ending value. And again, you're going to end with either a parentheses or a bracket. Okay, you can have a combination of them. Okay, so each number you actually need to evaluate whether or not it's a parentheses or a bracket. The range, on the other hand, is the vertical axis, right? It's the y values. Okay, so we don't care about left to right when we're speaking about the vertical axis. We care about bottom to top. So it's going to be parentheses or bracket, and it's going to be the bottom starting value. And then comma, the top ending value. And again, we're going to end with either a parentheses or a bracket depending on the situation that we have. All right, so for the next example, we're going to look at some graphs. So you're going to want to pause the video or whatever you need to do to be able to sketch these with me, and then we'll determine what the domain and range are. So for this graph, let's just go out 3 in every direction. Kind of a little off-spaced here, so I'm going to spread that out a bit. So what I want you to do is I want you to put an open circle at 1, 2, 1, 2, and then a closed circle at 3, 0. And then I want you to connect them. Okay, so we'll look at the domain and the range of this. We'll fill this in here in a minute. So let's look at a second graph. So again, let's keep it fairly simple. So let's just go out 3. And for this graph, let's just draw a parabola. So let's do a parabola that got shifted up 2. And again, we're going to determine what the domain and range are. Okay, so remember, domain, I only care about left to right. Okay, and I only care about x values for that matter. So what is my leftmost x value? Notice I start my graph at 1, but then you have to ask yourself, am I including that 1? Okay, and the answer is no, because it's open. So I'm going to use a parentheses at 1. Okay, and then the second question is, what is my right ending value for the x, right? So notice I end at x equals 3, but this time it's a closed circle, which means I use a bracket. Okay. But then for range, it's not left to right, correct? It's the vertical axis, so I look from bottom to top. So the lowest y value I have is 0, and it's solid, so I include 0. Okay, and then I'm going to go up to a y value of 2. Okay, and notice I used parentheses here because up at 2, it's an open circle. Okay, so a lot of times you might have a mixture of parentheses and brackets. Okay, and by the way, both of these, something like this is going to show up on your comp exam. Okay, so the competency exam, the skills that you're supposed to know ahead of time before entering this class, that would be something that would show up on that. Okay, so for the domain, notice I want left to right, but if you think about it, if this graph keeps continuing, it's going to go on forever to the left and forever to the right. So how we say forever in math is we use the term infinity. Okay, we always use parentheses with infinity, never a bracket. Okay, but then range, if we go bottom to top, our lowest y value is 2. We're going to include that, and then we go up to infinity. Okay, so you'll definitely need to practice a couple of these. So on your homework, there'll be some varied graphs that you need to look at. And so really these are visual exercises. Like once you learn that domain is left to right and range is bottom to top, it's really just a matter of you practicing different types of graphs. All right, so the last thing I want to touch on is maybe a little more about domain. So maybe said a little differently, domain is what the x values are allowed to be. Okay, because there's a couple of rules that we want to make sure that we don't break. And the first one is we cannot have 0 in the denominator. We learned that a long time ago, right? 0 in the denominator is not allowed. And the second thing is we shouldn't have negatives under a square root. negatives under a square root mean that we have imaginary solutions, but traditionally, when we're talking about what x can be, it shouldn't give us an imaginary answer. Okay, so for the final two examples for today, I want you to tell me what the domain is. And I want you to do it in interval notation. So let's say that this is my function. This is what we call a rational function. We'll talk more about these later on in the semester, but for now we're just looking at the domain of this thing. Okay, we know it's a function based on the f of x notation. That means, yes, it's a function. Okay, so what we don't want to happen is we don't want the denominator to be 0, right? So you can probably just eyeball and tell what the denominator would not need to be, right? So notice x cannot be 2 here. Okay, and it can't be 2 since that would make the denominator 0. Okay, so notice we've talked about what x can't be, okay, but domain is actually what x values we can have, or which ones we're allowed to have. So I like to visually look at this on a number line. Okay, so here's 2, and we want to say, hey, it is not allowed to be 2. X can't be 2 because 2 gives us 0 in the denominator. But x can be anything to the left of 2 and anything to the right of 2. Okay, so when I go to write my domain in interval notation, I basically have 2 sections, and I just need to pay attention to my graph. If I go from left to right, the domain can be anything from -infinity to 2, and then anything from 2 to infinity. Okay, the symbol we use to combine multiple sections is kind of a little fat capital U looking thing. It's actually a little wider than a U, but this stands for union. Okay, so the answer for what x is allowed to be is actually anything from -infinity to 2, not including 2, and then anything not including 2 to infinity. Okay, so in other words, it's actually really important that you use parentheses here because we're actually trying to make sure 2 is not included. It's the only off-limits value for x with this equation right here. Okay, so let's do one with a root in it. So g of x equals 2 minus x, or sorry, the absolute value of 2 minus x. Okay, notice still a function, right? Because we have function notation here. Okay, so rather than focusing on what I don't want x to be, I'm going to focus on what I do want x to be. Okay, notice I really want this to be a positive value. So I'm going to say I really want this to be positive values only. Okay? In other words, I want what's under the square root to be greater than or equal to 0. Okay? Greater than or equal to 0 means positive values only. Okay? So now if I want to know what x is, I would subtract 2 from both sides. Remember, everything keeps the sign that's in front of it, so this would look like negative x is greater than negative 2. But notice I don't really want negative x. I want to know what x is. Okay, so for this one, I would divide by -1. So it's probably been a minute since you looked at this, but when you are multiplying or dividing by a negative number, like we did just then, you need to flip the inequality sign. Inequality just means not equal to, so it means like less than, greater than. Okay, so in other words, I'm going to have negative x divided by -1, which is going to make that a positive, but then this greater than or equal to is going to flip over to less than or equal to 2. So I'm going to circle that, okay, but I'm not quite done because I still want to know what the interval notation for this is. So again, I think a number line picture can help us. So here's 2. Notice it's less than or equal to, so I want to include 2 with a solid circle, and I want to cover things that are less than 2, which means I need to travel to the left. So if I look at my graph from left to right, my domain is everything from negative infinity to 2, including 2 this time. Okay, if this were an open circle, I would use a parentheses, but because it's a closed circle, I use a bracket there. Okay, so notice this section is a lot about domain and range, but really domain is probably the more important of the two, because the range, the y values are set only by whatever the x values are. So the x values are known as the independent variables. They're the ones that can freely change, and so they're the ones that we're talking about a lot of the times. And then depending on what x values we have, we plug those in to get the y's.